Welcome. Today we'll start switching techniques. At first we will see circuit switching techniques. So where circuit switching is used, basically for the telecommunication, the circuit switching is used. That's mean in PSTN, public switch telephone network, that kind of circuit switching is used. And for data communication, the different other switching techniques also used. And circuit switching also can be used. Now, suppose there are two devices and we want to communicate in between these two devices. Suppose we have a particular device, and we have another particular device. When we established the connection in between these two devices, that is called the point-to-point communication. But how we can perform this communication in between two devices when there are many devices? So if we want to point communication in between many devices, suppose there are other two devices, suppose this is another device and this is another device, suppose there are total 4 devices are there. So if we want to do the point to point communication, then we have to, the one solution is mesh topology. That's mean you have to establish a mesh topology in between all these 4 device. So if we this way we can establish a mesh topology. But what will be the problem if we increase the number of devices? But this mesh topology is impractical for large number of devices. If we use a large number of devices, then this kind of mesh topology is really impractical. So then the solution is different switching techniques. So what are the different switching techniques? The first one switching technique is circuit switching. The another switching technique is packet switching and message switching. These are the 3 different switching techniques basically used. Now, what is circuit switching? So for circuit switching, communication via circuit switching implies that there is a dedicated communication path between two stations. So for circuit switching, there should be a dedicated, at first you have to establish a dedicated communication path. Suppose take the example of telephone communication. So if we want to communicate with other telephone, then at first we have to, through the dialing, we have to establish the communication path. Then we establish the communication, and at the end of communication we disconnect the connection. So basically circuit switching is this kind of technique is used. So in the circuit switching, suppose we want to communicate from the device A. Suppose this is the device A, and this is the device D. So if we want to communicate from A to D, then what to do? At first we have to establish a communication link. That's mean that is called the call request signals. So that's mean at first we will establish a communication in between A and D. If we can establish a dedicated line between A and D, then the acknowledgement is sent. That's mean the communication is established. Then we send the message or data. Then data will be sent over this dedicated line from A to D. And after communication, the circuit will be disconnected. So this is the basic. These are the 3 important. So at first, 3 important steps. First step is circuit establishment. The second step is data transfer, and third step is circuit disconnection. In circuit switching, we can implement the circuit switching using different way. The first approach is using the space division switching. The second approach is time division switching, and third step is the combination of space division switching and time division switching. These are the 3 different way we can establish the circuit switching. So at first we'll see what is the space division switching. In space division switching, the signal paths are physically separated from one another divided in space. That's why it is called the space switching. Now we'll see what are the different way we can establish the space switching. One one method is to establish space division switching, that is called the crossbar switching, and second way is multi-stage switching. There are some drawbacks of crossbar switching. Then to overcome that thing, you can use the multi-stage switching. Now let's see what is the crossbar switch. So suppose there are four input stations and these are the four output stations, and all these are the communication nodes. So basically here it is a semi conducted gate, and through some control unit we can either establish the connection through this gate or we can disconnect the communication through this gate. That's mean using some control signals these gates will be on and off. And then suppose if you want to communicate from 2 to 3, suppose from the input station 2 you have to establish the communication in between the output station 3. Then at first you have to on this cross point, you have to on this cross point, you have to on this cross point, and through this cross point. So all these cross point you have to establish the connection in between all these cross points, and ultimately you can send the data from to these stations to that stations. So this is a one crossbar switching techniques when there will be four inputs and four outputs. So as well, so if we increase the number of inputs and number of outputs, this matrix will be enlarged. That will be larger matrix will be used. But this crossbar switching have some specific limitations. What are those limitations? The first one is this will be costly for large switch. That's mean if the input is increased large number, then this matrix will be a huge matrix. So that will be the and all this switch is the metallic switch. So the cost of the switch, the whole cost of the switch will be very high. So that will be very costly. And the second limitations, suppose any one of this cross point is failed. So the failure of the cross point prevents connection between the two devices. So if any of the cross point is failed for any reason, then the connection will be dropped. So that is the another limitations. And the third limitation is the cross points are inefficiently utilized. Suppose when all the stations is connected with other stations, then also all the switches, all the cross points are not utilized. Some cross point will be unutilized. Suppose if we establish the connection between these 2 and 3, only 1, 2, 3, 4, 5, 6. This cross point will be this 6 cross point will be utilized. The other cross point will not be utilized. That's why the inefficiently utilized. It is inefficiently utilized. Then to overcome these things, we can use the multi-stage space division switching. So multi-stage space division switching, suppose we will take an example of 3-stage space division switching. This is the example of a 3-stage space division switching. So here the crossbar switches is splitted into smaller units. So all these are the smaller units. The whole cross point will be divided into smaller units. The previously that was 4 cross 4, but it is 4 cross 2, 2 cross 2, 2 cross 4. So it will be smaller units. And it is possible to build a multi-stage switch with fewer cross points. And here the number of cross points is decreased from the previous example. So in the previously the cross point was huge, but here the cross point will be fewer. Using the fewer cross point, we can construct a multi-stage space division switching. Next, time division switching. Time division. So here, the time division switching can be implemented in two ways. The number way in TSI, that is called time slot interchange. TSI, time slot interchange technique. Another is TDM bus technique. So let's see what is TSI. So suppose all these are the four stations, and through a channel we want to communicate with other four stations. Now the the packets will be sent in different time slots. So this is the first time slot, second time slot, third time slot, and fourth time slot. So in the first time slot, the D station send the data, then second time slot C station send the data, then the third time slot the B station and N station. And if we don't use the switching techniques, then the A will be reached on the A station, B will be reached on the B station, C will be reached on the C station, and D will be reached on the B station. But if we use the switch, that's mean in between, if we use the TSI, time slot interchange slot, then this particular sequence may be changed. So this sequence is changed. So in place of A, C will come. In place of B, D is come. In place of C, A is come, and in place of D, the B has come. So now at the A will be sent to station 3, then D will be sent to station 2, C will be sent to station 1, and B will be sent to station B. That's mean using this TSI, we can change the time slots, and this way we can do the switching. So that is called the time division switching. Now the third approach is combination of time and space division switching. So this is the example of time and space division, combination of time and space division switching. Basically here the space division switching is done, and here the time division switching is done. So we can implement the switch using the two techniques, time and space division switching combination. Now, what are the drawbacks of circuit switching? The main drawback of circuit switching is for circuit establishment and circuit disconnection, some extra overhead and delay is required. Every time you have to establish a circuit, and after communication you have to disconnect the circuit. For this reason, some extra overhead will be required. Number 2, channel capacity is not utilized properly, because channel capacity is dedicated for the duration of the connection even if no data is being transferred. So once the communication is established, via some nodes, then what will happen? Suppose this is the node A and this is the node D, and through this line the communication is established. Then until the communication channel is not disconnected, the channel will be occupied by these two stations, station A and station D. So that's why this is dedicated duration of the connection. Number 3, this will be inefficient for burst data transfer. That's mean huge number of data. When we transfer the huge number of data, then it will be inefficiently used. And other users cannot use. So suppose when a particular line is dedicated in between two stations, then other user cannot use that, even if it may be free of traffic. If it is free of traffic, then also the other user cannot use that dedicated line until that line is not disconnected. So all these are the different drawbacks of circuit switching. Thank you.